For centuries, we humans have been looking up at the night sky and drawing what we've seen. First, just using the naked eye, then by using telescopes.
The detail and skill in some of these drawings is outstanding. Like this one, taken of an observation here at the Royal Observatory in Edinburgh. It's a piece of art. However, our scientific knowledge was totally transformed when we could photograph what we could see.
There's something about a photograph that can make you feel that you're right there. Up close to the moon, a planet such as this one, a star, a galaxy, whatever you're looking at. But it's the information contained within that picture which is really important.
Having the light from those distant objects fixed in an image like this one has allowed astronomers to analyse and understand the beautiful universe around us. So tonight, we're visiting the wonderful world of astrophotography.
Welcome to the Sky at Night.
Astrophotography is both visually stunning and scientifically important. NASA's latest space telescope has started sending back incredible pictures of the cosmos. And of course, there are also thousands of amateur astronomers all around the world regularly photographing the night sky.
In this episode of The Sky at Night, we're going to take a trip down memory lane.
I've actually brought some clips with us.
You can point up at exactly the time it's going to happen, and the guests think you're doing magic because this amazing flare will appear in the sky.
Take a look at the future.
We have 3 cameras here, 3 different channels that allow us to cover the spectra continuously, the entire wavelength range, going from the visible all the way to the H-band in the infrared.
That's the Orion Nebula.
And see what you can do with the latest technology today.
Wow, and that was with a smartphone. But first, Chris has been looking at some photographs which have changed the world. Well, the world of astrophysics, at least.
Ever since the early days of astrophotography, pictures have played an important part in our understanding of the cosmos and our place within it. I'm meeting Dr. Jen Gupta from Portsmouth University to talk about some of the images that have inspired her.
Hey Jen, how are you?
Good, thanks, yeah.
Nice to see you. Well, I can see we've got plenty of photographs to talk about. But before we get into those, why is astrophotography useful in your work?
Well, my job is all about, getting people excited about space, and using photos like this is such an important part of it. For me, you can't give a talk about astronomy without using these images, and they're absolutely stunning. And when you can then get into the science of what's behind those images, I think is where their beauty really comes in.
Where should we start?
Let's start over on this side, if you want to bring those over.
OK, so this is a galaxy. I recognise this much, but it's a special image.
This is an image that was taken by Edwin Hubble, so not Hubble, the Hubble Space Telescope, the actual person, Hubble, back in 1923. There was a photograph taken at Mount Wilson of the Andromeda Galaxy, M31. And the thing to notice here is this little marking here where there's an N that's been crossed out and VAR with an exclamation mark.
Right, yes.
Very excited.
So what does VAR mean?
So this is Edwin Hubble realising that this little dot there is not a nova, but is a variable star, a particular kind of variable star called a Cepheid variable, which meant that he was able to use these photographs of Andromeda to actually calculate the distance to the galaxy.
Because these stars change brightness in a regular way, and you can work out the distance.
And it actually turned out that Andromeda is way outside of our Milky Way, so it's kind of solved the problem of what galaxies were.
Right, and sort of increased the size of the universe by a factor of millions, just with one set of observations. Where next?
We're going to jump another 30 years or so.
OK, I recognise some of these.
Yeah.
Yeah, there's a galaxy for you.
So this is all images from the Hubble Space Telescope, named after Edwin Hubble, of our Andromeda photo. And, you know, when we look at these images, these ones kind of here at the top are the ones that you always think about. You know, that was my computer background. That's on my water
I
bottle
had
at
a
the
phone
moment.
case of this on. This
Exactly.
is the Pillars of Creation.
Yeah.
This is the star-forming region. This is famous, right? This is what people think space looks like.
Yeah, but the one I want to focus on is this one, which doesn't look as impressive, maybe doesn't look as pretty, but this has just revolutionised our understanding of the universe. So this is the Hubble Deep Field. It's an image that was taken by pointing the Hubble Space Telescope at a tiny patch of the sky that looked completely empty and just focusing the telescope there again and again over about, I think, 100 hours over the course of 10 consecutive days, and then stacking all those images up, processing them, and seeing what happened. And this is what happened, and this image contains nearly 3,000 galaxies.
So almost all of these dots are galaxies.
Yeah,
right? there aren't many stars.
There's a handful of stars. You can see them with their little diffraction spikes, any of them with a crossover. But almost every blob of light in this is an entire different galaxy, which is just mind-blowing.
What about our last set of images?
Well, I've gone something a little bit different
Right.
for the last ones. I thought I would bring us closer to home. So less about kind of the science behind it and a bit more about thinking about kind of, you know, our place in the universe. So, you know, we've got, this is the blue marble, the photograph taken by the Apollo 17 astronauts, December 1972. I always show this whenever I give a public talk because, you know, everyone who was alive at that point is in this photograph, apart from those 3 astronauts.
Right.
Who were...
There's something about the fact it was taken by people that makes that one special,
Yeah.
I think. Because
Yeah.
we're now used to seeing this image from satellites and so on, but this is...
But look at, yeah, I think this was literally camera to the eye, point and click out of the...
Basically the world's best holiday photo.
And this is just a small sample of the amazing array that Jen had to show me.
Now, we've talked about photos taken with the largest telescopes in the world and with satellites launched by space agencies. But astrophotography also belongs in your back garden.
So I've been into astronomy since I was a small boy, but it wasn't until I became a teenager that I actually tried my hand at film photography. That was a bit of a disaster because I ended up flooding my bedroom, so I gave up on that. And it wasn't until a number of years later that I got a digital camera, and I can remember looking through the telescope at a really bright moon and wondering what would happen if I put the digital camera to the eyepiece of the telescope and take a picture. That's what I did, and I got a great shot of the moon, and that got me hooked into digital astrophotography. Now, some 18 years later from that, I find myself making a living out of astronomy, and I feel really privileged for that. But there has been somebody that has been with me throughout. So I've invited him to my house, and we're going to have a little chat about how things have developed over the years.
Pete!
Hello,
Hey,
Chris.
how are you?
Very well, thank you. And you?
Yeah, good, good. It's really lovely to be in your garden, which I've seen on telly.
You're very welcome, Chris.
Now, I thought we'd talk about your time on the Sky at Night, and I've actually bought some clips with us. So, should we just play?
OK.
On October 28th, there was a total eclipse of the moon. I didn't see it. I was clouded out.
Oh, I remember this.
It was completely cloudy in London as well. We have had some nice photos from people who were luckier, though. This one from Pete Lawrence, just a mile down the road from you here in Selsey.
A mile from me, he got a clear sky and I was clouded out, the way things go.
Do you remember that?
I do remember that. I think that was possibly my first photo on the Sky at Night. But actually, there's a very important tip for any astrophotographer out there in that, because it was completely cloudy for that event, apart from one tiny gap which appeared. So I stayed out for the entire thing looking at cloud for most of the time. And it's tenacity. If you actually make the effort and you stay there,
that's when you'll get the shot. And it was always thrilling, obviously, to have a photograph on the sky at night, so...
Yeah, well, you must have made an impression, because it was only a few months later that we invited you to our first Sky at Night star party
I
in
remember
Patrick's
that
Garden.
very well.
I think I've got a clip of that now. Yeah, let's pull that up. Just an hour ago, it was completely cloudy, but the skies have cleared, and behind me you can see the young crescent moon and nearby the planet Mercury. A great shot for our astrophotographers.
We left Chris outside with some cloud trouble. I wonder, is there anything better there now?
It's 1:30, it's raining, and the satellite photo shows cloud for the rest of the night. So all we can do is shrug and hope for better luck tomorrow. There have been highlights, though. I enjoyed seeing the moon and Mercury from the beach. One of yours. And others have got some great results.
I remember that photo well.
Those wonderful images. It's fully dark now, and it's a crisp, clear, if a little cold night. We're looking at Comet Machholz. Deep sky objects are being imaged. Saturn is well placed, but I could just see Jupiter rising. So far, night 2 couldn't be any more different from night 1.
Oh,
I remember it's dawn this. And I can see Scorpius fading into the brightening sky.
I do. I remember
It's been a
brushing the frost off my charts, actually.
I enjoyed myself. What have been the highlights?
And you're still there.
It's
just the two of us.
Well, that was our star party. A definite success, and I hope you enjoyed it.
Well, there's some interesting things there. I remember the photograph of the thin crescent moon and Mercury because I set up on the beach itself, on the sand. And because of the time it takes things to happen in television, the tide had come in and it was actually lapping up around the tripod legs. But we did manage to get a good shot of it.
The thing I remember about the star parties, apart from the fact that they were great fun with people camping in Patrick's Garden, you didn't quite know who you were going to run into. I remember Terry Pratchett turning up to one with a bat detector for some reason. But the variety of things that people were looking at and taking pictures of is astonishing. There's all sorts of targets people go for. So it's not just about creating beautiful images. I think this one's excellent. This must be from, 10, 12 years ago now, I think.
OK.
Good evening. We meant to devote this programme entirely to the eclipse of the sun, but something else very interesting has happened. A comet or asteroid or something has hit Jupiter and left obvious traces. With me, Pete Lawrence, Chris Lintott. Pete, you've actually photographed this.
I have, Patrick. I mean, this is an incredible feature in Jupiter's atmosphere. It was first discovered by Anthony Wesley in Australia, who imaged it on the 19th of July. And after his announcement, I managed to capture it myself, and there it was, this incredibly dark region towards the southern part of the disk. Yes, this is something which has hit the planet and left this dark scar on the planet's gaseous atmosphere. As amateurs are looking at it, and they've had a lot of interest in it and announced its existence, we're monitoring it and finding out how the thing is changing over time.
Yes, and as you say, Pete, it's not the amateurs have done a great job in discovering and monitoring this, but the professionals have been paying attention as well. It's a really good example because we wouldn't have known that had happened if it hadn't been for amateur astrophotographers. Though I jump in with the professionals at the end. We're still reliant on people with the kind of telescopes that are behind you to tell us what's happening.
Well, it's the early warning system, isn't it?
Yeah.
Really, that these are happening. And the beauty of the amateur network is that it's working all the time, and people are obsessed with taking pictures of Jupiter constantly. So if anything like this does happen, then the alert goes out and everybody looks for it. But yeah, no, there have been several impacts which have been picked up, and it's a new thing, isn't it, really? Because we weren't sure what the frequency of these impacts were, and it's a great thing to study.
I've got one clip which I think my favourite Pete Lawrence clip. This is how to use astronomy to impress people. Now, I think the next most famous class of satellite will be the Iridium flares, at least from an observer's point of view. What are they?
Well, the Iridium constellation is a group of satellites which was put up there as a global communications network. And once you've seen an Iridium flare, it's almost impossible to believe you've missed them because they are absolutely fantastic. And it's actually quite a neat party trick. If you know one's happening and you happen to be at a party, you can point up at exactly the time it's going to happen and the guests think you're doing magic because this amazing flare will appear in the sky.
Now, have you ever actually done that?
Possibly.
But
I think I did it once.
yeah, I mean, it works. People are impressed. It's better if it's the space station. But it's interesting. I went back and looked. We made that whole programme about observing artificial satellites.
We did.
And I think you'd speak differently about it now. There are so many more satellites, and they're basically a nuisance now.
I'll be perfectly honest, I've never been a big fan of observing artificial satellites because, for me, the pleasure is looking at natural stuff and trying to work stuff out about it. And we know a lot about the satellites which are up there, so they are a curiosity. I'm quite happy to go out and take a photograph of the ISS going across the sky or across the moon or the sun because it's a technical achievement to do it.
So how has the technology changed? Like, how is your setup different from what you had 15 years ago?
That's a really interesting question because it hasn't changed that much in terms of the hardware. I have bought new cameras, lots of new cameras, but the actual telescopes themselves are still the same.
Yeah, and I do think that the variety of images that we see, I think people have got more, perhaps more artistic.
Yeah, partially driven by astrophotography competitions, of course. The technical aspect of trying to take a photograph of a planet will result in something which a planetary scientist will drool over.
Yeah.
But, of course, from a photographic perspective, it just looks like a planet in a dark sky surround.
Yeah, well, there's plenty to see, and it's been fun to look back at the past with you. But while we've been looking at the past, Maggie's been up in Scotland looking at the future.
The Very Large Telescope, or VLT for short, is the most productive ground-based telescope here on Earth. Located in Chile, it consists of 4 individual telescopes that can work on their own or in unison. And to date, it has produced a vast array of fantastic data.
From the last breath of a dying star to amazing infrared images of neighbouring Jupiter, as well as many, many galaxies in incredible detail. The Very Large Telescope has captured it all. But our engineering capabilities are always improving. And the latest upgrade has been assembled here at the Royal Observatory in Edinburgh. I am meeting Dr. Oscar Gonzalez, lead scientist, to tell me more.
Oscar, lovely to meet you. And you're introducing me to MOONS. Now, with most of these instruments, MOONS is an acronym, I assume.
So MOONS stands for the Multi-Object Optical and Near-Infrared Spectrograph.
OK. So what sort of information are we talking?
So say, for example, from a star,
Yes.
when we're observing the spectrum of a star, what we're actually looking at is what chemical elements are in the atmosphere of this star. So the light comes in from the fibers, and as I said, they're ordered in this line in what we call a slit. So then we have all the fibers ordered that way. They go down into a collimator that orders the beam of the light into the right angles, and then it goes into a set of dichroic filters that is in charge of splitting the light, either reflecting the light or letting the correct wavelengths of light passing through.
So when taking an image of, say, a star, MOONS analyses all the light of the different wavelengths, which enables astronomers to understand the chemical composition of the target object.
So, yeah, when you say dichroic, that's a filter that will let some wavelengths pass through and reflect other wavelengths. So then you can split it into the 3 different bands.
Exactly. We have 3 cameras here, 3 different channels that allow us to cover the spectra continuously, the entire wavelength range, going from the visible all the way to the H-band in the infrared in the system you have above.
Is there one camera missing?
There is one camera missing. The camera is actually sitting in a clean room at the moment, being worked on. Then it will be brought up here, closed up, and do another set of tests.
But now we've talked about the light arriving and going through the system. But how do we get the light in? You know, this fiber placement system.
Yes, of course. So if you come with me, I will introduce you to my colleague who will show you how this is done.
Fantastic. Thank you.
Each large camera will be capturing images that are 4,000 by 4,000 pixels, which is needed for the amount of light coming in from the optical fibers.
Hi, Steve. Lovely to meet you. I've just been finding out about the instrument, but this is the way of getting light into the instrument, so the fibre positioning module.
Yes.
And I must admit, it looks quite complicated.
Oh, yes. Yes. So eventually this will have 1,000 what we call fibre positioning units, which is each one of these. At the moment, we have 655 on the plate, so we're in the partial state.
You're working on it.
We're working on it, yes.
Yes. Now, you've got one of these. Can you talk me through it?
So it has a fibre attached to it, as you can see.
Yes.
The light enters the fibre at the tip of the fibre positioning unit here.
Oh, yes. So that little tiny hole?
There's a tiny aperture there, and this moves on an image plane that's generated from the telescope. And the light from whatever the galaxy or the star that you want to look at is collected into there via, there's a small lens that focuses it into the fibre. This then positions that within its own little patrol field. And because you have two arms, there are different lengths. It doesn't move in a circle, it moves within like a donut-shaped patrol field.
But donuts don't seem that useful because there's a bit in the middle which you're missing then.
Absolutely. So each positioner cannot reach its own central axis. It relies on one of its neighbours to do that.
OK, so that means, yeah, your next-door neighbour can get to the centre of yours, even if you can't.
Yes.
Can we see it in action?
Yeah, you absolutely can, yes.
Each of the 1,000 units will move independently to capture the light coming from their own specified target. Tightly packed together, it takes precision engineering to ensure they avoid collision.
So it's been wonderful seeing it here in the lab, and it's lovely to see how it's progressing as well. But I can't wait till we get first light on the telescope and start getting that wonderful data. Look forward to that.
Yeah, me too. Thank you.
Thank you.
Astronomers around the world will be looking forward to getting their hands on the data from the Moon's cameras when it's installed next year. But you don't need expensive, complicated instruments to capture images of the stars and planets. Anyone with a smartphone can give it a go, and it's a great introduction to the hobby. I invited Peter Lewis to discover how he photographs the sky at night.
So, Peter, welcome to my garden. Great name, by the way.
Thank you.
So what got you into astrophotography?
Well, when I retired about 7 years ago, my family decided that I needed a hobby or an interest, and they bought me my very first telescope. I started looking through and I thought, well, that's really great, but wouldn't it be great to be able to capture what I could see with the naked eye?
Yeah.
And that's when I started, really, to try and work out how am I going to actually do some proper photography. I didn't have a real expensive camera to do it, so I decided to use my phone, which I was able to share across the internet with people as well, and learn how I could do better.
Fantastic. Well, that is actually one of the joys of astrophotography, that you can actually take these pictures and share them with everybody else. So can I have a look at some of your pictures?
Of course you can. Yeah. This one is a photo of Saturn and Jupiter when they reached the Great Conjunction in December 2020.
I remember that very well, yes. Okay. Fantastic. So when you took the photograph of them without a telescope, did you just hand hold it or did you put it in some sort of mount?
No, handheld. Inevitably, if I was taking a photograph with a long exposure, then I would put it on a stand or a tripod. Or sometimes what I've done is just balanced it on the edge of my telescope.
Or just rest up against something so you're not wobbling as you're taking the shot.
Exactly. In fact, in the past, I've literally balanced the phone on the car roof to take the photograph using a timer, because inevitably you need to use a timer because you're going to knock it over as soon as you press the button.
That's the problem, isn't it? As you press the button, you're actually physically touching the camera, and that introduces a wobble. So have you got any advice on settings to use?
Most of the time I use a night sky facility which allows a sort of 2 or 3 second exposure.
And that's built into the phone rather than a separate app?
Yeah.
OK, so what else have you got?
OK, so in this particular photo...
That's the Orion Nebula.
Quite a familiar sight through a telescope during the winter sky.
Wow, and that was with a smartphone?
So it's just using the smartphone, just connected again to the eyepiece of the telescope, and that was using a 3-second elapsed time.
Wow.
So the idea, obviously, was to try and capture more light and some of the colour that you get through the nebula itself.
That's an amazing shot. I mean, what we've spoken about so far have been taking pictures of dots, which are planets, which are sharp, pinpoint sources of light. But that's a diffuse object, and that's come out really well. Well, thank you very much. That's been very enlightening, and I'm amazed at the photographs you're taking, and it's a great privilege to meet you. Thank you very much.
And thank you for asking me.
As Peter has shown, there's plenty that can be done using your phone. And as you develop your skills, you can take ever more amazing pictures like these.
There are a number of interesting events coming up over the following month, and some of those will be of interest to visual observers and some will be of interest if you're trying to get into astrophotography. We start with a very special event on the 14th of September, when the 77% lit waning gibbous moon will pass in front of the planet Uranus. Now, Uranus is pretty dim. It's right on the threshold of naked eye visibility, so you'll need at least binoculars to see it. The event starts with Uranus being hidden by the bright edge of the moon at about 10:30 BST, and Uranus reappears from behind the moon at 11:20 or so. Now, those times will vary slightly with location, so it pays to get out 10, 15, 20 minutes earlier than the times I've stated. On the 17th of September, the moon will have reduced in phase to 58% lit, and it will be really close to the planet Mars. Now, this is a great opportunity, if you have a phone camera, to try and snap both objects in the sky. Give it a go, see what you get back. On the 24th of September, Io and its shadow can be seen transiting Jupiter's disk if you've got a telescope. So look at Jupiter from about 3 o'clock in the morning through to about 5 o'clock in the morning, and you'll see this moon and its shadow crossing Jupiter's disk. Now, they'll be really close together, actually, the moon and shadow, and the reason for that is that Jupiter is near to a point in the sky which is called opposition, when it's opposite the sun. When that happens, then Io's shadow drops almost behind it, directly onto Jupiter's disk. Jupiter's opposition occurs on the 26th of September. On the 28th of September, there's a chance to see Ganymede and its shadow transiting Jupiter. This is from 5 o'clock in the morning. Ganymede is the largest of Jupiter's 4 Galilean moons. In fact, it's the largest moon in the entire solar system, so it's quite a sight. Finally, on the 8th of October, if you can find the bright moon in the evening, shouldn't have any trouble with that, then bright Jupiter will be right next to it. And this is another great opportunity to try and get a photograph of this pair if you have a phone with a camera attached to it. So go outside, see what you can get, and if you're new to astrophotography, good luck.
If you love finding out more about our universe, there's lots of other ways to get involved this coming month. The annual Astronomy Photographer of the Year competition will be announcing this year's winner on the 15th of September, with photos on display at the National Maritime Museum from the 17th of September.
For those of you who prefer the outdoors, then the Our Place in Space Trail will let you explore our very own solar system. Upcoming locations and dates to be announced shortly.
And finally, the Exmoor Dark Skies Festival will run from the 13th to the 30th of October in Somerset. Featuring over 50 events, there'll be plenty to get involved in. For more information on these and other events, go to the Sky at Night website.
So whether you're taking photographs, attending an event, or just taking the time to stop, look up and enjoy the night sky, there's always something to discover. Next month is our Question Time special, where, with the help of our expert panellists, we'll be answering your questions. So until then, good night